and you all in person, but nevertheless, we look forward to this interesting session. I request you all to message your questions in the chat box so that we can go through them in the end. To introduce you all briefly, the Kanvinde Memorial Lecture Series is a platform to create design awareness and excellence. It is an attempt to pay humble respect to the legend whose excellence in design has set newer milestones. The platform's objective being to create awareness about contemporary design practices by hosting prominent designers from across the country. The series started in 2010 with the inaugural lecture by architect V.V. Doshi. Further, we had eminent architects like architect Karan Grover, architect Kamal Malik, architect Madhav Joshi, architect Brinda Somaya, Professor Akhtar Chauhan, architect Jaisim, architect Sanjay Mohe, architect Jonas Widodo, and architect Patrick Schumacher. Last year, we were happy to host architect Anu Mridul and Shilpa Mridul. We are glad to have architect Manitan Sonali Rastogi here for our speakers for this year. But before we start with our session, I would request our principal, Dr. Anurag Kashyap, to welcome you all. Over to you, sir.
So, thank you, Arati. Just a moment. Sharvester, I'm online now. Okay. Sorry. Uh, I welcome Sonali ji and Manish ji to our most prestigious lecture series, Kanvinde Memorial Lecture Series. Sonali ji and Manish ji, they are the very dynamic leaders of today's architecture profession. Their works are very inspiring, and my students are glad to receive both of you here. Sonali ji had been to our college, but Manish ji, I think so far have not visited our college. I would like to give a brief introduction that what BNCA is all about. Dr. Bhanuben Nanavati College of Architecture for Women. Our college belongs to our parent institute, Maharshi Karve Stri Shikshan Sanstha, which was founded way back in 1894 by the great visionary of India, Maharshi Dondo Keshav Karve. He was later on awarded Bharat Ratna for his very exemplary work for women. Emancipation of women through education was his motto. And in 1994, I happen to be the founder principal of this college, and we have completed 27 years, and recently we entered into 28th year of the college on 8th of August this year. When we started this experiment of college only for women, everybody was a bit apprehensive, including all Indian authorities, and everybody was, including myself, of course, that whether this experiment of only for girls will work or not. So we used to discuss that, and authorities sanctioned only 30 intake on experimental basis, whether we can run the college or not. But soon, in last 27 years, all my girl students proved that we can be one of the best in India, not only in India, but in Asian subcontinent by proving their merit by winning many awards, by extraordinary achievements at international level. I would like to name a few. We have our college has become global, and it's no more local by having more than 50 international collaborations under 4 heads: student exchange, faculty exchange, joint studios, as well as joint courses with 50 international universities. And I think it's a record in India by itself. We are also part of United Nations. we are official partners of United Nations under United Nations Academic Impact Program. BNCA's girl students have worked on 12 international projects of United Nations, and 10 are in the pipeline for the future. And that's why United Nations declared our college as United Nations Activity Hub. Apart from that, we are also part of the Oxford Union for the project of Universities of Future, and we are the member of the Roundtable Conference till 2024. With this particular achievement, we can give our students world exposure, and students understand what their level is in comparison with the rest of the developed countries of the world. Apart from that, uh, apart from BRs, we also have 3 master's courses. We founded Masters in Landscape Architecture in 2006 for the first time in Maharashtra, Masters of Environmental Architecture for the first time in India in 2006, and a Masters in Digital Architecture in 2011 with Fab Lab. Apart from that, we also award PhDs under the auspices of University of Pune, and we have currently 33 candidates pursuing PhD, which makes us one of the biggest PhD research center in architecture and related subjects like planning, landscape, and environment, etc., etc. So, in 1994, the authorities who were a bit apprehensive in giving us the permission that whether only girls' college will work or not, I hope that they are now happy with this wonderful progress, and especially about digital architecture, which I would like to tell you something, which I think Sonali and Manit will definitely appreciate. That we founded this course in 2011, and in 2014 we founded our Fab Lab, and we became the first to incorporate 3D printing. We have 10 3D printing machines at the moment, uh, 3D printing, laser cutting machines, fully automatic, CNC machines, as well as we became the first to incorporate 6-axis robotic arm, which was inaugurated at the hands of none other than Patrick Schumacher himself. Actually, we had invited Zaha Hadid, but we never expected that she will depart so early. So Patrick Schumacher took over, and he inaugurated our Fab Lab. Also, we have Keppel Lab. These 2 labs are for the first time in India in any architecture college. So I would like to extend my invitation to Sonali ji and Manit ji to kindly visit our college the moment the lockdown opens up and this pandemic gets over. So I'm absolutely glad to have both of them, Sonaliji and Maniji. They are the leaders, today's leaders of architecture profession. And our students, they keep getting inspired. Our faculty keep getting inspired by both of your works. And now we are very eager to watch your presentation here. And I'm sure that you are going to continue to be the leaders of India for architecture profession. So thank you so much, and I welcome again Sonali ji and Mani ji for this our very prestigious AP Kanvinde Memorial Lecture Series. Thank you so much, and over to Arti.
Thank you so much, Kashyap sir. It's always a proud moment for us to hear when we are working with BNCS. I would now like to introduce you to our speakers, architects Manit and Sonali Rastogi. Sonali and Manit Rastogi are internationally renowned architects and the founders of Morphogenesis, one of India's leading architecture and urban design practices, with offices in Mumbai, Bengaluru, and New Delhi. The firm reinterprets India's architectural roots and consistently employs passive design solutions for a unique contextual language. Its work encompasses a range of typologies across architecture, interiors, and landscape urbanism. The practice is the recipient of more than 116 awards, which includes being India's first WAF award winner, 5 IIA awards to its credit, and laureates of the Singapore Institute of Architects Guest Award. Its work has featured in over 1,000 publications and journals, both international and national. Morphogenesis work has been published in a monograph by Images Publishing Australia under the world-renowned Master Architect series, a first for an Indian firm. Today, they will be speaking on the firm's copyrighted design process SOUL, SOUL, an acronym for Sustainable, Optimized, Unique and Livable. These parameters define the inquiry process that shapes the architecture of morphogenesis, an architecture for a sustainable and resilient future. Sonali and Manish Rastogi, sir and ma'am, we are here. We are looking forward to your presentation. So over to you.
Good afternoon. It's an honor to be here at the NCA, and I really do wish
Screen is not shared. Great, thank you.
Good afternoon. It's an honor to be here at the NCA, and I really do wish I could truly be amidst you all. But as situations are today, I'm just glad to be here with you all in this way as well. I'm deeply honored to be associated with the name of Mr. Kanvinde, who is a legend, and to be here today in this memorial lecture established in his name is an honor for any architect. But it is specifically interesting for me because my inspiration to be an architect was really my father, who's also an architect, late Sri Ashok Kumar Srivastava, and his inspiration and mentor and guide and his first job was with architect Kanvinde. And I think through my entire growth-up years, his name would always crop up as my father's inspiration and how Kanvinde sir would have done this, how Kanvinde sir would have done that. And that inspiration seemed to be alive in all my conversations. So today to be here is really an honor for me. It's not just celebrating Kanvinde ji, it is for me also celebrating my mentor, my father. So on that note, I also feel that when I read up a little bit more about what Sri Kanvinde talked about as an architect and what I'd heard in my childhood, I also felt a huge sense of alignment, which I think his words are such. They talk about technology, they talk about people, they talk about building for people, they talk about learning from vernacular. Now, these are things that have always been true. They are true today, and they keep changing the form in which they are true. So I think in that sense, I find alignment, and I think so will you all. And now I will just kind of rewind a little bit back to how morphogenesis was started and why I have the honor to be here introducing morphogenesis and Manit and myself to you all. This was the mid-90s. Manit and I were students at the Architectural Association London. And we would often talk about the fact that how come it's so rare that Indian architecture comes up for display at exhibitions, for galleries and debates. It's not that there isn't architecture going on in India. It's not that there aren't thinkers. I mean, at the end of the day, our country has always been famous for great architecture. When you Google India, you will end up seeing more pictures of buildings more than anything else. And then, of course, the people of India. So, but just for us, it was a little bit of a hiatus in the debate global debate. And we just felt that we need to do our role of bringing Indian discourse back into a global framework, or rather more strongly back into the global framework. And we need to play a small role in doing that. And which is how the idea of morphogenesis began. And Manit, my partner, also my spouse, was deeply engaged with thinking about how nature designs and what the processes are to think like nature, and hence the term morphogenesis got evolved. So it was more out of the way we were doing design inquiry in the 90s, where the philosophy of morphogenesis was created, and N90 morphogenesis was formed in Delhi. Over the years, we have practiced architecture that has a backbone in sustainability, optimization, unique and livable, and the acronym being SOUL. It's not always been the acronym, and it's not always been this much clarity. We learned along the way that how we wanted to orient our minds, our thinking, which was always informed by people, informed by other architecture. But today, 25 years later, we know that soul is the backbone of all the work that we do and hope to do. On that note, I will let Manit explain some of the projects that we have worked on with this philosophy, and time permitting, I will also take a few projects and explain them. Thank you very much.
My presentation today is about building resilience, and till about a year back, we used to call it building sustainability, and I think we sort of looked at not changing sustainability, but increasing the scope of sustainability to encompass many other factors which we used to think about, but didn't sort of analyze with the rigor that we were analyzing our buildings in terms of sustainable design. India is one of the largest populations in the world, next to China, with about 1.4 billion people. But urban India has all the sort of issues that large emerging nations have. It has water issues in our city. Climate change has affected India tremendously. We've had some of the worst weather patterns in the last year or so. We've had issues with energy. We've had issues with pollution. And some of this led to a lot of our early thinking why we would pursue the whole sort of genre of sustainable design and see if architecture, if buildings, the whole built environment can help resolve what our politicians and what our cities over the years have not been able to do. So very early on, we sort of looked at what's really the issue with energy. And we did this study about a couple of decades back. At that time, India's population was 1.2 billion, and now it's about 1.4 billion. And just very broadly speaking, in terms of the fact that India has a daily solar radiation, which is on an average 5.5 kilowatt hours per square meter of the country's mass, we only really need 0.03% of this land mass if we were to just drive our entire energy by solar. It's actually nothing. It's only 2% of the baseline, the deserts of India, is all that we would need to drive all the energy, not for today's requirement, for what is projected for 2050. And then the second part is water. And if you just look at the annual rainfall, I know this is very macro level data, but it lays the context of what we would do at a micro level, given the fact that energy wasn't a problem, but it is. Water isn't a problem. 2% of the rainfall in India harvested would suffice 150 liters per person, for 1.4 billion people. And so what are we really doing? And we were sort of, looking at our cities, and we were looking at our buildings, and we had developed this sort of system where our buildings would consume energy, and they would consume water, and they would generate waste, and it was a one-way flow. What you see on the top here is through this process of sustainability, where our main aim has been to push our projects to net zero energy, net zero water, fresh water, and net zero waste to landfill. Optimization has been mostly about how you build less. how do you do a lot more with a lot less? And essentially that's about removing embodied energy, and that's about reducing CO2 emissions from how you build something. Uniqueness is about, again, a set of metrics which looks at tradition, heritage, and culture. And that third philosophy and third arm goes from the fact that across India, given the fact that price points of construction are extremely frugal, everything started looking the same. It didn't matter whether you were in a cold climate, in a temperate climate, in a hot climate, in a warm, humid climate. But more by and large, most buildings in India started the same. And that's because they were adopting processes of construction and design that allowed for that to happen. And we found ways of digging into the past to find ways to build the future. And that's where we sort of got the livability. And livability was essentially about engaging not only the client and the end user of our buildings, but trying to engage the people who built that building. Now, when we talk about energy saved, CO2 emission, and fresh water, this is all benchmarked to the ECDC, the Energy Conservation Building Code of India, which is like a green building standard. And based on that, those standards, all our buildings are in the post-occupancy evaluation. And we keep a track of those numbers, of what these buildings are achieving today. And that's over 2.5 decades. So, starting the first project, this project dates back about maybe a decade or so. It's called the Pearl Academy. It sits in Jaipur. Jaipur is in Rajasthan, and it sits in a desert climate. There were many challenges to this project. The first, of course, was the fact that cost. Now, I'm sure a lot of people here don't know, may not be familiar with cost of construction, but this project was built at $200 a square meter with all interiors and all the energy infrastructure, everything all told, which was virtually impossible in that time. And of course, a climate like Jaipur, which goes up to 48, 49 degrees Celsius in the summer, but can drop to close to zero in the nights in winter. And we began thinking about how we are sort of going to be able to build this building. The first thing that came to our head was to throw out air conditioning. Because we throw out the air conditioning, along with that, you reduce all the electrical equipment, but more so, you reduce the fact that the power generation is also done locally. So you have the diesel generating sets that generate that power, and you get rid of that as well. And we studied a lot of the traditional architecture, we used computational models to understand how do step runs work, why are they cooler at the bottom than the top. We understood evaporative cooling, jollies, ventilation, shading. So we mapped out 200-kilometer radius. We said every material that we use will come from that, because transportation costs are extremely heavy. And the other thing that we discovered at the time was that the temperature of the Earth about 3 meters below the surface is equal to the average temperature of the region. And in Jaipur, like I said, which goes from 0 to 48, 49 degrees, the average was sort of floating around 25. And it's really, that's a very useful. And which is why the step wells, if anyone has visited India and they go to the step well and you come down, it naturally feels cooler, because the earth banking along with evaporative cooling is a phenomenal cooling mechanism. It's an underground air conditioner, naturally driven. So we said, fine. Now, typically speaking, any institutional building in India would be built as a block, and then you would sort of have the open space, which is the recreation space. But when you're in a desert climate, that open space is really worth nothing. And these large outdoor spaces become mostly unusable through the year. And we said, well, we won't do our building vertically. We'll spread our building out and use the whole building as a shade, like a tree. And therefore, the space under the building will become viable. We did a very optimized, simple rectangular form. Idea was again to decrease the amount of surface area that gets exposed to getting heat gain. And we went through a series of courtyard morphologies. The idea really being to keep the sun out, but let the daylight in. I'm not going to show you these diagrams. All of you probably know them very, very well. But the idea really was to develop, and because it was a design and fashion school, the emotional element was that if you were inside this sort of very rigid form, which was driven by our environmental criteria,
in any courtyard, the courtyard should not be sort of like a rectangle and enclosed. It should sort of flow freely like a Mobius strip. And that was sort of the model when we began over about a decade back. To achieve the parameters of, without air conditioning in a desert climate, we sunk down 3 meters. We recycle all the rainwater, and we recycle water from the toilets by filtering and using a treatment plant. And we created our own step well, Bavli, in effect, which allowed for evaporation through the courtyards and cooling the building internally. And that sort of negative space, if I may, was pulled out of the program. So we were supposed to build about 25,000 square meters. We did. We built about 2/3 of that. And that entire area underneath, which to date operates at about 28, 29 degrees Celsius naturally, is used for an outdoor cafeteria, is used for various functions, performances, etc. And that whole underbelly section was designed to do that. These are just some of the pictures of that sort of step well that we created. All the water is harvested, not a single drop of water leaves the site. But we were just trying to do, just work with limited resources effectively. And obviously the whole thing sits in shade, it captures the wind flows and it cools the building down. We looked at insulation. Insulation was very critical for a project like this in a desert climate. And there was a local community that made pots. We couldn't afford the sort of very expensive 50 mil glass wool or rock wool insulation. And we thought that pots, which were used traditionally, would make for great insulation, but air is a great insulator. And we use these inverted pots with a layer of screed on the top, and we use that for insulation. The pots were made on site by this local potter community. For the external skin, we kept our window to wall ratios very, very optimized. We are at about I think 20 or 25%, providing adequate daylight. And we created this buffer space, which is essentially a service space and a screen. And the screen is made from, again, a set of local community who make cement concrete jalis on a very simple system. And we ran all our services on the outside. So the screen allowed for the fact that the entire windows go blinds free, and the design of the screen changes based on the orientation. And all the services are openly accessible. The sprinklers run here. We use the sprinklers as a facade cleaning system, because once a month they are supposed to test and flush it. So that sort of cleans that up. And that's the building when it was finished about a decade back. So all the materials, the stone, everything here was from within a 200-kilometer radius. We did achieve the price point. And this building went on to become very popular with various schools of architecture. They've gone and studied it. We've had students from various programs in masters programs studying sustainable design, recording temperatures and seeing it. And for the last decade or so, it is sort of consistently in the summers, when external temperatures have hit 47, it's hit 29 degrees inside without air conditioning. It runs on an energy performance index of about 25 to date. Very simply, we get the bills that just divided out. And whilst it was being built, it gave a certain level of employment to the local community. And that gave us a lot of inspiration. And we thought that, if it was possible to get an 18 degrees delta by passive design, and it was possible to create something in these sort of kind of price points pushed by the adversity of price, then what is it that we could do as we moved on? And that's when we started sort of putting more formal metrics. And which is why I'll jump to a very different kind of building, which is the British School, which is in Delhi. That's a composite climate. And here budget was not an issue. And our brief was, to begin with, because it was the British School, was that they wanted it to be centrally air conditioned. All British schools pretty much across the world are either centrally heated or centrally air conditioned. And we argued the fact that if we can begin to achieve as much as we can naturally, then we will do so. And this project is about, I think, 6 or 7 years ago. And we then spoke to the clients, which was essentially the High Commissioner and the board, and we said that why don't we look at this 5-acre site and generate try and do India's first net zero energy, net zero water, net zero landfill, waste to landfill kind of building. And I said, fine, let's give it a shot. And so we did the math on the water, and we, from the 5 acres of land that we had, I'm not going to go through the calculations, but we could support a population of about 1,300 students. And we said, we'll do this in reverse. We said, so the notion of carrying capacity comes from the fact that what the land can afford in terms of water and energy is all that we will build. And 1,300 students work very well for them. Now the problem with a city like Delhi is all our rain is concentrated in 3 months. You can't store that much water for the rest of the year. So what you do is you dig down and you find an aquifer that's pure, and you use that as an underground tank, and you use that as an exchange. So you put water back into it and you pull it out of it. And over the year, you go net zero on water for 1,300 people. We took the same 1,300 people, and then we went about this, building out how much, because we needed to build about 20,000 square meters for fitting out an IB school. And we were trying to work out what is the correct ratio of rooftop solar to number of levels that we would need to be able to get to net zero, and therefore what would be the target EPI that we need to achieve. And after a lot of to and fro, we came to a 4-story building with a target energy performance index of 56 kilowatt hours per meter a year. Now that number would by necessity drive a lot of passive design, where a lot of the heat loads and a lot of the lighting loads would need to disappear. And that's when we would be able to be net zero on water, net zero on energy. And again, we look at a lot of, in Delhi, there's a very old city called Shahjahanabad. We looked at how those morphologies worked, how some of the earth banking worked. The other also key area was safety and security. And because we were propagating the idea of having open corridors, and we were not doubly loaded and had them air conditioned, the issue of security, CCTV cameras, and we came up with this idea. We didn't come up, we studied this idea of eyes everywhere. And if you look at any old vernacular evolution of any city anywhere in the world, where there was, in those days when there was no police several hundred years back or CCTV cameras, the cities were designed in a way that there were eyes everywhere. And that really was a security. So a combination of the two factors, we began to look at morphologies where we would be able to get eyes everywhere, step terraces, shaded courts, and we sort of landed up with this sort of model with a rooftop area sufficient to make this into a net zero energy project. Some other small things that we did, we put the labs on the top because the labs are constantly mechanically ventilated because of the fumes, and that automatically creates a buffer for everything underneath. We created natural voids for the wind flows to allow for the courtyards to function properly. And because of the orientation of the site, where we had pushed that form again from like we done earlier, we began to look at the Jali formation. Most of our teaching areas were on the northeast and the northwest, while the southwest was essentially a large screen just shading out the courtyards. A lot of this was built on site, so we came up with this sort of construction methodology of again full windows and having a secondary screen. The screen, of course, varies its opacity and density based on what's behind it and what orientation it works to. And yes, and that's sort of now the completed building. We did a lot of modeling for. So we had the classroom, and that was built, that was done perfectly. But to us, what was more important was to be able to create enough open spaces within which would be comfortable through the year. And we were targeting a delta of about 8 to 10 degrees in perceptible temperature in the outdoor areas in the school as compared to the external temperature. And then here's that project. So that's the front screen that shades off the southwest. and sort of creates a full microclimate behind. Again, open corridors. What you see here are air filters because it was a British school. We didn't air condition the entire school, but we did for the classrooms we did, and then create these sort of passive spaces. A lot of outdoor spaces. Well, this is a bit old, but the trees are grown now. Yeah, and that's the school. Now, on our post-occupancy, we to date have an EPI of 52. It's the only school in India right now which got a GRIHA 5-star rating. GRIHA is India's own green rating system. And as I am a founding member of the green rating system for, I can say that I had, it is genuine. I didn't falsify any data, but it's operating at a 52. Now, what you see here is a combination of surface temperature and air temperature. So, and then we sort of map that back to perceptible temperature. So at a 44 outside, we did manage to get a 10 to 12 degree delta in all the open spaces inside that school. So to date, and we keep our classrooms at about 26 to 28 degrees. So there is a gradation as one steps out and moves through this entire project. And it operates today as a net zero on all accounts. So that was in that sort of composite sort of climate. I mean, like in a composite climate, the winters aren't a problem. The real problems are, and it's not even the summer because shade, thermal mass, screens, a bit of evaporative cooling, that works. The real problem has always been the monsoon. Why it works really well in schools is that Indian schools are shut in the monsoons. That's the holiday period, and that sort of works really, really well, which doesn't in other kinds of typologies like offices or residential and which sort of brings me to this third one. This is a campus. It's a 100-acre campus for a very large technology ID firm called Wipro. They're amongst the 3 largest listed companies in India. And they do these sort of really massive campuses, have tens of thousands of people working there. This is located in Hyderabad, in Telangana. It's a very strange sort of climate. It's not very adverse, but it's got a tremendous amount of diffuse radiation. It barely has no cloud cover, pretty much through the year, and temperatures do go up, but it's not that high. And it has reasonable wind speeds, reasonable wind temperatures, but the glare is just incredibly high. The diffuse radiation is what pushes temperatures up. And we worked on this project with TransSolar. It's one of the several we've done with them. And this is where we began. So we looked at the site, and that's about 100 acres. It's divided into 3 zones. And that zone 2, as we discovered, was largely unbuildable. Because it sat in a radius from a lake which wasn't too far away. And even as we discovered, it's sort of a bit low-lying. And the really buildable areas were these 2. We again pursued the idea of a carrying capacity. We had the 100 acres and we worked out backwards as to how many people can we support from the rainfall. And we then to store that water, because like I said, Hyderabad is very strange in the sense that its entire geology is slate rock. So it was very hard to get to an aquifer and do water exchange with. So we really had to build a reservoir. So at a 4-meter depth, we needed about 15 acres of water reservoir to support 15,000 people working there. And again, similarly with energy, we worked out that if we hit a 60 EPI, then we will be able to, with 15 acres of a solar farm, which we have planned over and above the water reservoir. So essentially, the solar farm shades the water from evaporation and picks up the energy. We will be net zero on both accounts. And that's what we really did. So we identified the low-lying area. Everything slopes there. We got a natural rainwater. It's a 15-acre lake, about 4 meters deep. And then it's sort of got the solar panels that sit on top of it and on the site and shade it. And that piece of the land will never get overshadowed. So we could do the solar farm, 15 acres on the site itself. And that sort of set up the basis of the first series of master plan. The second exercise was, as I'll just go back, was how do we begin to hit a 60 kilowatt hours per square meter per year, of which 25 is on primary energy, which is lighting and air conditioning or ventilation, and the 35 is on equipment. And how do we begin to get our building to work with the 25? The 35 was a given, so that's all internal equipment. The question really was, how do we work to 100% daylighting on the floor plate, and how do we bring our air conditioning requirements down to a point where through the year, and to remind you, these buildings tend to operate about 10 to 12 hours a day, 365 days a year, because they're essentially very large tech companies. So we began this exercise where we did about 8 of them. We did many more, but we sort of isolated 8 morphologies which were built upon isolated single towers, a series of square towers, courtyards, a hybrid of the tower and the courtyard, mid-rise high density, low-rise high density, micro courtyards, and we came up with several morphologies heuristically. And then we began to test them. So various kinds of ground coverages, various heights, and we then put them through a series of analysis. So the first analysis that we did was, of course, for wind, because wind was critical for us to, if we were to hit that 60 EPI, which is 25, we also needed to be able to get a lot of the functions from inside the building out. And a lot of the functions to run passively without air conditioning. Of course, where the essential work was happening would be air conditioned for various reasons of, the data centers, they need very tight control on air conditioning, etc. But how much of this could be and for that we needed the wind. Now, predominantly Hyderabad had an east-west wind, and we put all these various forms. We selected 5 that performed reasonably well. We then put them through the horizontal plane. We were trying to look at what, in terms of seasonal solar radiation, would the insulation be on the lower planes, and basis that we picked up a certain scheme. We then looked at daylight autonomy for each of these 8 or 9 different schemes, and then again began to identify. And this was a highly iterative exercise between wind, solar radiation in the open spaces, and daylighting within the internal spaces, and what morphology would suit it the best. And finally, we selected the option which was sort of the micro courtyard option. And after doing a series of CFD runs on it, we cleaned up the entire the model. Again, this was highly iterative. And if anyone is very good with algorithms, this is a great one for that kind of process. And then we sort of finally ended up. So the first phase is what is now under construction, which I'll take you through. And then we've already done the urban design for the remaining 3, so that in a sense, the wind flows, the evaporative cooling, the shading, all those parameters remain the same. Coming to that first phase, which is approximately about 1 million square feet, about 100,000 square meters. We began looking at the outdoor spaces, and we went through a series of analysis, looking at a combination of having no roof, no fans, no dry misting, and having only a roof, like a lightweight tensile roof, a combination of roofs and fans, plus dry misting. And we then did a cross analysis of the fact that what would be the financial savings vis-a-vis these spaces sat inside air-conditioned spaces. And that sort of led to this design, which I call a large desert cooler, very traditional large. Desert cooler is essentially what used to be there before air conditioners, a box with a fan, and you had these this sort of hay on the side where water ran down, cooled it and shoved it through. And so the entire plane, which sort of sits on an elevated podium, was designed for those wind flows and those outdoor spaces. And we worked with SBP. We got this sort of height with this sort of tensile roof in combination with Transolar and us, and we sort of got this entire outdoor space working in a way that it is comfortable through the year. So it's comfortable for rain, it's comfortable for the summer, it's comfortable for the winter. And by and large, this entire outdoor space now takes on primary functions. I won't spend too much time on the indoor spaces. We went through a similar exercise of looking at various kinds of mechanisms of how can we remove as much air conditioning from the inside, whether it's underfloor, with heat recovery, hybrids, low velocity fans, and came to an optimal solution. Again, a lot of this is very cost-based, but it's also but it's a combination of sustainability and cost. And of course, settling for the fact that our client agreed to an internal temperature of 28 degrees, which was very useful because, and it's actually correct, because external temperatures can go up to 38 to 40 degrees, and working out the whole system based around that. So when when we finished the design, 56% of the area was in under air-conditioned space, but consuming about less than half the air conditioning. So typically speaking, in this region, a building would consume 250 square foot for 1 ton of air conditioning. This project is operating at about 650 square feet per 1 ton of air conditioning. So even though 56% of the spaces are air conditioned, they're consuming less than half. About 35% have been moved to natural ventilation. Now, when I say natural ventilation, and I say the third piece, which is shaded outdoor, all of these are achieving thermal comfort conditions through the year. Greater than 90% of thermal conditions through the year. So not only did we manage to get about 10% of that area outside, which is about nearly 10,000 square meters. So cafeteria, gym, recreation, library is in that outdoor shaded space that I was showing you. We have outdoor meeting rooms, which were removed from the inside area, and of course the rival plaza. And in the naturally vented spaces, we have various other functions. So effectively, only half the building is air conditioned. And this typically would be at 100%. So that's it. Thank you very much.
Yes, wonderful. Aarti ma'am.
Thank you so much. Thank you so much, sir. Over to you, Sonali ma'am. Sonali ma'am, would you like to talk about it?
Yes, Sonali ma'am, your
Yes.
audio.
Yes, sorry, I was
perfect,
just
perfect.
getting my technology sorted. Yes.
No problem.
Can
No
you,
problem.
do you see the screen?
Yes.
Yes, we do.
Okay, so this particular project is something which is very, very close to my heart at Morphogenesis. It is located in Rajirhat, just outside Kolkata, or rather probably like in Kolkata in a way. And why it's really important is because not only does it follow all the sustainability criteria that Manik spoke about right now, but we also saw in this complete west-facing project an opportunity to actually bring in the culture and make this totally unique from the hue of soul. Okay, and do you see the screen move? Hello?
Yes, we do. Yes, we do.
Okay, so this particular project was entirely west-facing. It has IT buildings, it has a hotel, it has a corporate office, it has a convention center, and it has residential. So it's a complete mixed-use project. Now, it is located in Kolkata. And Kolkata, in many ways, people from Kolkata consider, or Bengal rather, consider themselves as completely seeped into culture, philosophy, art. And so this is something that we wish to capture, because we felt that, we always talk about context, and right from the time we start studying architecture, that how relevant context is. And in the case of Bengal, the art, culture, philosophy cannot be, has to be the primary criteria when we are discussing context. So along with climate and seasons, we married together the idea of the notion of Bengal in terms of art and craft. Now, then we went ahead and arranged the buildings in such a way that we created kind of little wind tunnels, and we did some study of how the wind moves, which you can see out here. And the buildings were arranged so that when people are walking, they are walking predominantly in an accelerated wind area, because Kolkata is humid. So if you can get rid of the humidity, it's really nice to be outdoors. And so the project was designed with people who would be mostly going up and down a central spine, which is kind of the buildings are placed close together. So it kind of creates this tunnel in which wind moves. And then as you move along the seasons of Bengal, which is Grishmo, Borsha, Sharat, Hemanto, Sheet, and Basanto, which are clear seasons, which all have their own festivals, have their own symbolism, and have their own weather. And based on that, the landscape was designed so that there is a constant variety for people to move through rather than just a long corridor, and experience really belong to the place. Then we moved on to the morphology of the building. Now, typically, in IT buildings, one will see very large floor plates and so on and so forth. But luckily here, we convinced the client that doing floor plates, which was 17 meters wide, would allow most of the people, rather all the people, to be working in daylight. Okay, and be close enough to actually have a sense of the outside, always inside. And of course, all of these were simulated using softwares that I'm sure our students, you're all very competent with that. And then we kind of use this formula of shifting the floor plate, sliding it along each other, because at the end of the day, core, structure, all of these things are extremely important to be at one location and not kind of move around everywhere with the building. And this was the formula by which the shapes of these buildings were derived. So whilst these are very large floor plates, what you see in front of you, that by slight shifts, almost 100% of the floor plate gets daylit. And that sense of like just sitting in massive halls is done away with. And there is the ability to subdivide floors into various offices depending on how the building gets used eventually. So this is a sketch which shows how the sun moves and how therefore we have taken the entire west facade and east facade and completely blocked it. And the long facades are in the desirable north and south orientation of the project. Now, these are the images of Kolkata and of Bengal, which inspired us. And you will find a lot of those images in the sketches. Tagore inspires not just every Bengali, but inspires the world. So Tagore is very much part of their soul. And we decided to make it part of this project for its uniqueness and its identity and its contextualization. Now, how did we go about it? So Kolkata has a large artist community, and Shantiniketan, which was a university set up by Tagore, is not very far. And there are a lot of sort of impoverished artists, for the lack of a better word. So what we did was we actually, along with the client, put out newspaper advertisements where artists were encouraged to come on a particular day. They were given a stipend and they were asked to work on the ideas of the seasons and culture of Bengal for this entire museum walk, where you see the image at the bottom, because this was going to be the covered walkway which is connecting the entire site. And not only the buildings, but it's like an outdoor art gallery that has been created here, simply because this is Kolkata, and literally I think every Bengali considers themselves associated with art. So these are all the crafts communities which have work once a year, but rest of the time they are incredibly sort of jobless, frustrated. So these were the people who were invited. These were the sketches that you see. A lot of sketches came in, and actually very detailed sketches came in, very, very detailed. Now, as architects, it was our job to sustain these communities and bring their ideas forward. And to sustain them, the art had to be translatable into building, and building at a very frugal cost. So their line work was, they were explained how to simplify it, how to minimize it, so that a certain amount of basic cutting can happen with CNC machines, because it's not possible today, and it's not desirable to have people carving a Taj Mahal for 20 years. It's not possible, and that's not what today's technology enables us with. So we got them to understand how to bring their artwork down into simpler graphics, which could be basically cut with CNC machines and come to site. And then these various sculptures, which you saw on the previous slide, helped us to finish the work. And then it went up on site. So this is an image. On the left-hand side, you see what was conceived, and then with the images put in there. And on the right-hand side, you see renderings of it. And designed as partly air-conditioned and partly ventilated. But for the ventilation, almost in a fun kind of way, Tagore's work was reinterpreted. Rather, his work, which has to do with, you can see the words that have been picked up, darkness, light, flame of light, nights and days, passing of nights and days. So in his poems, he talks a lot about the environment, talks a lot about the movement of the sun, wind, rain, and all the sensory sort of beauty of that poetry. We try to capture it in kind of almost a crossword puzzle. And this crossword puzzle, by the way, was designed in our studio. Of course, we had it vetted by a Bengali professor, but the crossword puzzle is designed that it read either which way. It talks about various segments of Tagore's poetry regarding the environment. So we've actually gone literal here in order to create an identity and also to engage with it in a different way. Even a child can engage with this. Even somebody just crossing over to office, somebody looking from that building, seeing through the glazing some of the alphabets, will always try to find an alphabet that makes sense to him. And here is how the entire western facade of the building looked on sketches. And now I'd like to show you the image of these facades going up. And as you can see, the using technology where it has been dry, the stone has been dry clad, the base work was done with CNC machines. Then, as you can see, the craftsman polishing it, some kind of polishing, some chiseling was done on site. So here, ideological involvement of the crafts community was there, and it will be there to stay in posterity for as long as these buildings live, as well as a large amount of employment was generated. So something unique was created by using the people of this region and using their craft. So you can see this image is showing you all of this going up in a modern drywalling methodology, and you can see the sketches taking shape. And here is some more of it. And now here the lighting is getting tested on site. And when finished, it will look like this. It's not that far from finishing. These photographs are a couple of months old. Now, the energy performance index that Manit has already spoken to you a lot about, we are targeting only 43. Now, this is less than 50% of Griha 5-star rated building. Okay, now by simply using the logic that we are taught in second year and third year of architecture school, that just block out the west, block out the east and west as far as possible. And that has achieved most of what we set out to achieve. And for example, minimize HVAC loads at less than 1 watt per square foot, window wall ratio at 25%. Now for this, we are able to create what I have been told looks quite magnificent at extremely low price points, because we lowered the energy consumption required. So everything installed is lesser electrical load, lesser air conditioning, therefore you buy lesser, therefore lesser generator. So just making sure, so in this project, it had to be commercially viable, which meant the floor plates had to be efficient, had to be functional, that can be used by one, can be used by multiple tenants. We did placemaking, which is upholding the unique and livability criteria by creating wind through the site where people walk. We promoted culture, which for us is also a part of sustainability, because without social sustainability, there is just no way forward. And it is very much, I mean, we strongly believe at Morphogenesis that it is our duty to involve all of those who are involved in the art of building. Then we went into the sustainability parameters, and where we will be saving endless amount of money annually from energy, and we have created a 75% less load on the freshwater supply. So which is how the building is also cheaper to run. I'll move on to this project, which is one of this very small projects of Morphogenesis called the Lodzi Community Project. And we call it a prototype for self-sustaining off-grid hill architecture. This is in the lower Himalayan ranges, 1.5 hours up from Rishikesh. And when we built this site, this little road that you see coming up to the site, that didn't exist. So that little hut on the left side of the image was a little Gaushala, and a couple of a small production facility, which is in white for forest essentials, was here, but you had to scramble up the hill, okay, for the last kilometer or two. So there was no road. There is zero electricity supply here, and there is only spring water. So this particular project was built with 67 people working to build it, of which 64 were from this hill. It produces the entire product, which a lot of the ladies and maybe gentlemen in the audience will know, sells by the name of Forest Essentials. So everything you see in a Forest Essentials shop is produced in this facility. So can you imagine all of that production happens without any electricity or water? And it exports the product to over 120 countries. And what is the most interesting part is through this pandemic, they barely ever shut. Because they're on the top of the hill, nobody ever comes there. Whoever comes to work here just walks up this hill and goes to work. And these are people who did not have to relocate to find jobs to cities and then be left walking 20 days to their villages across the country. So that's why we call it a role model project to exemplify decentralized growth. This is truly architecture by the people. They built it. It's for them because it gives them employment, and it is by them. And it is their herbs and their things that they grow on these hilltops which come there and make the forest essential product. So the 64 people who built it, all the few people are maybe similar number that works here, supports 800 people, which is the total number of people on this hill, 150 hutments, and it has re-energized the entire village. And they are not, I'm certain, these villagers will never migrate to a city to find themselves homeless and literally disenfranchised of every culture that they know, of breakup of families where the fathers are or mothers are in the cities for 1 year and go back once a year. None of that will happen. The family and the social fabric will be intact on this hill at least. So the design was really simple. They have a style of building here called the Kholi, and we actually looked at the Kholi planning, and we put the high thermal mass where it was required, the manufacturing halls below, and the packaging halls on top, based on the way they build and they live. So they store things below and they work on top. And that's exactly how we did it. We can slope the roofs, of course, in this climate where it kind of drizzles every day, sloping roofs are desired, but we chose the slope angles, which were different from the way they traditionally slope, simply to catch the right solar power generation roof form. And this is our typical wall sections, which were built with cavity walls and stone cladding. to get the right thermal mass. And this is a cross section showing all the functions that happen over here. Now, this is, this is very, very pleasant. As you can see from the data above, it's very pleasant climate. It wasn't an uphill task to actually make this net zero. But I think what I want from all of you is to have the want to do it. It was not our client brief, but just the product that they make, which is herbal, local, just inspired us to think in that way. So now you see during construction. So they actually, when you go past this, go up the hill, come to this and go down a little bit from the hill is the local school. So a lot of the kids during construction would come because their parents were building this. And this is during construction pictures. Now, we used all lost and found objects. There was wood reclaimed from some old hutments over here. There were leftover pieces of purlins. The wash basin stand is made out of reinforcement. And you can see this is the finished product sitting on top of the hill. These are all people who helped build with the building, and now they work in here as well. There was a gaushala near the site, which we maintained. You can see the cow with the gaushala behind. And actually now the product from the cow is used in the factory. The rooftop of the factory is to catch the sun to dry the herbs, which is why we could have actually added more solar power. But we actually figured out how much they need to carry out their activities, and that was left available to them in the sunniest spot. And you can see this on the top right, how little the project is on top of this hill. And these are the children who actually come in the afternoon, and they use the terraces because the drying is stopped by 2:30 in the afternoon. Then the kids use the terraces as classroom. This is the project, which it's very close to my heart. It makes me feel that really it's not just one nice architecture. It is a totally off-grid architecture. And this is how success can be brought to remote areas of this country. Now, I'll go to a completely different sort of project. This is Zydus Corporate Park. And it is, it's a lot in the news now because our new vaccine, Zycov, has come out of this. This, again, is a west-facing project. And that's why we actually chose certain kind of projects, which I want to tell you now about the aesthetic of these west-facing projects. In most of our country, we shouldn't be opening up a building to the west. Okay, in the hot climate, in the hot parts of our country, which is a majority of it. But then that also provides you with a canvas. It provides you with the canvas. It provides you with uniqueness. It provides you with imagination. Now, in this project, again, we worked with reinterpreting crafts. We worked with a reasonable amount of local community, and we addressed the hot and dry climate. So the series of walls that you see are like this. So these are west walls, which are facing the highway. Here, the temperature when measured due to the heat island effect went up to 58 degrees. So, and this is the highway. It's Ahmedabad Gandhinagar highway. So we entirely blocked out the west. And then when we were looking for inspiration, we looked at the kansaras and the utensils we all know from Gujarat and also Rajasthan, neighboring state, where those beautiful metal utensils are the tradition. So we looked at saying that why can we not take inspiration from how they take inspiration and how bending metal has been part of this Kansara community forever. And today, technology allows us to convert it into much larger format than a utensil. And these were some plugins to Revit, which helped us, Dynamo, which actually helped us create walls which were built with 1700 points. And you'll be surprised, not even one point was missed in the casting. So here you see how metal workers inspired us to create a wall which is doubly curving. So, and I think some of you will get very excited if I use the term parametric. And so these are the walls. Now, what I also want to tell you is you see these little shiny pieces. Now, these shiny pieces are mirror work. Okay. Now, this is the tradition of Gujarat. Gujarat is recognized for its mirror work. And we all wear it in our clothes. But for those of you who've ever studied the origins of this mirror work in the Bhuj area, it was used as identity. They would do the round mud huts. And every house would develop its identity by using the way they put mirror work on their facade. So this building developed its identity and its dynamism with the mirror work. Now, this is the sun moves across the whole day, and these are dichroid mirrors. So they pick up different shades of the sky throughout the day. This building can never be shot in exactly the same appearance ever. It will change every single day, every minute, because of we picked up the movement of the sun, used the tradition of the Bhungas, and added modern day dichroid character to that mirror. So this is the explanation of how this was done. And sun, mirror, identity, all learned from the Bhunga community of Kutch. And this is the project going up. Of course, as architects, we like to create drama. And at the bottom, if as though this was not enough, at the bottom of this wall sits a reflecting pool. It was also actually it was a construction need, because cotton steel, which is the material used here, we stabilized it so that it doesn't turn black, but it will leave some color. That is the nature of this material. So the color comes into the water body and then gets cleaned, and then the water gets recycled. So, but it's also used as a reflection body. Now, the image to the right, where you see the full wall, I wish this was a live session, and I would take you to make a guessing game saying how long is this wall, but this wall is 200 meters long and 8 floors high. I think the image doesn't do justice. We're not being able to catch the height of this wall well. And then the wall also wraps around inside. And, so because I think part of that sense of that the outside is right there, the inside outside. And also, and then the wall curves in multiple ways. So the wall curves in the east side of the building, which is where all the courtyards are. And the wall comes and becomes the floor. So you can see it where people are working, the wall comes down. Again, there are water bodies at the base of it because we need to collect the color. So on that note, I will go and stop at this image. And I think I'll now open the house out with your permission to if any students have any questions.
Lovely. Aarti?
Thank you so much, Sonali. It was wonderful. I mean, we at every project we were just mesmerized. I mean, speaking about sustainability is one thing. Merging that with an architectural design, I think it was wonderful. I'm sure students are inspired looking at it. Students, do you have any question? I would request Mahesh sir to take over this session.
Yes, thank you. Sonali ma'am, could we have your camera on, please? Yes.
Yes, let me try. I'm a little bit.
You could stop share from here. Yes. Go on Zoom again. Yes.
Stop. Okay, I've done the stop.
Yes, correct.
Yes, I've got.
Lovely. Yes.
Yes.
So I'll just be quick with these two questions that I've already received. So I'm going to ask those. So just a moment. Yeah. Shruti is asking, ma'am, you showed us architecture that is highly sustainable, but also aesthetic. What do you do first, design or talk about sustainability?
I don't know how to separate the two. I think to think about architecture without thinking about sustainability is a mistake. Okay, so one has to train the mind to think of, it's like, I'll go back to how nature designs and what we were thinking about when we were in college. By no means the measures were we saying, okay, then I'll make a tree-shaped building. No, it is to understand that there are multiple parameters that go towards creating a complex object. Right? You cannot say this parameter is first priority and this is second. I can make, okay, let's say I can think about sustainable, beautiful, everything. And the client wants 95% efficiency on the floor plate, otherwise he cannot lease it. Right? That is an equally important parameter because that is a functional need of the project. Otherwise, the project cannot be funded. Right? And then there is no project. So it's all the parameters have to be simultaneously thought of.
Yes, I think that makes a lot of sense because what happens in the academics is, sorry, I'll just a moment, just internet is acting up here. What happens in the academics is the students talk about form first, then they get confused, then they want to do section, then they want to talk about sustainability, then they will redo the form. There's too much confusion in their design. So I think, yeah, it has to happen simultaneously is very important. There's another question from Professor Surbhi Gadkari. She's with BNCA. So she's asking, you involved a lot of artisans in the process. Do you specifically make a separate attempt to involve regional artisans? And how does it work? It's a give and take process. How does it work in terms of involving these people?
So, sometimes we involve people. Sometimes people become the inspiration for the design. Right? So, for example, in the case of the Bhunga inspiration, we were inspired. So step number one, as Manit said earlier, we not only look for materials around the region, we also look at what is the context. Like when you all teach your students, the first 2 weeks they go to site and they learn about context and they interview families and we do measure drawings and we find out the history. So we do exactly the same still. Right? And then sometimes we will find opportunity where we can revive communities or make their cause public. And sometimes we will be inspired. Right. So we got the Kansaras so a lot of the folding, like maybe 5 or 6 modules in the cotton steel folding were done by machines. But then all the junctions were all unique. Right. So we got some Kansaras, set them up on the site, and those unique junctions were all folded by them. Okay. And we actually had to use architects to try to translate which one of those 1700 points they had to fold and what did they have to achieve in that and how much folding did they have to do. But the bulk of it was done by machines. Okay, specific unique junctions were done by people. Right? But the Bhungas, we were just so inspired with learning that they actually create identity with the mirror work. It's not just decoration. So the child knows I have to run to this hut because he's used to that pattern language on his hut. Otherwise, all the round huts, how does he go? Right? So this is, and then the client desired a certain identity, and it was on a bare highway. So this work had to be iconic and make sense on a highway. Otherwise, I might as well have made it in a factory shed. Right? So then we got inspired, and I believe that we will play a role when this project is seen because it finished just less than a year ago. So when this is seen globally, hopefully, I'm hoping it will be seen globally. this art will percolate into the mind space of the world, and it will find another interpretation other than just clothes. Fashion designers have done a great job of it, but it will find another medium. And then
others will want to replicate it. Yes.
Yeah,
right.
and it will find more and more interpretations and more employment of these craftsmen. So maybe for my mirrors, I couldn't employ them. But then I think I played a role in spreading the idea of the craft. So sometimes it's idea, sometimes it's people, but it comes from the same kind of context that the professors, contextual studies and analysis that the professors teach the students in architecture school.
Yeah, that we keep telling them, but unless they see your work, they won't really take it seriously, I think. There's a question by Ayushi. She's saying, thank you, ma'am, for wonderful project shown. You spoke about net zero buildings. How easy is it to maintain them?
Very easy, because if there is hardly any equipment in it, then obviously it's much easier to maintain. I don't think there is any connection between maintenance and going net zero. In fact, if any at all, the lesser air conditioning you have, the lesser disasters you will have in that some equipment fails, something happens, the lesser chillers, the lesser generator sets. Obviously, it's easier to maintain. So, So I'm not saying that we shouldn't have, by the way, I'm totally for modern day requirements. So I'm not saying that the building should not be air conditioned and we should go back to vernacular architecture. I think you have to create an architecture which is right for the time and right for the function of that time. So if my client requires a fully centrally air conditioned building, of course he or she requires it. But how to minimize the energy load and to touch the earth lightly, as Glenn Marcus said, is the question.
Yes. I think video got, yeah. So I think that you showed very well at the start of the first project itself, and also Manish showed the first project where the building itself was acting as a shade for the whole ground, and I think that's where it was not troubling the ground much, but yet creating a space, which is very good. Yeah, those were the questions that we've got. I have a personal last question to ask. While you are trying to integrate these sustainable ideas and technology together, and which I personally feel is very seamless, do you think you have to use your creative liberty a little extra than the client requirement? As in, do you really not always follow that client brief, but try and not compromise on your ethos of designing? Do you push your design ethos a little on the client?
A lot. I think why would somebody not want a more sustainable building? Like, what is the reason? Like, there is no reason, right?
True.
Because a more sustainable building will always save money. So whether they're a believer in sustainability or not, as long as it saves money, it's good. So I never meet a client with whom I can explain to them that and explain it technically. Like, get all the engineering on board, get the MEP calculations, get the heat loads, say this is a saving. So why would anybody not? Then if within their budget, within their aspiration, you can give them something unique, why would they not want it? So who is going to come to an architect and say, make sure my building looks ordinary? Nobody is going to say it, no.
True that.
Right. No. So I just think that it's like, for example, if somebody comes and says, look, I think in my city, all the young people are very attracted to full glass buildings. Can you do a full glass building? Okay. So, yeah, I can. But then I will place the entire core and services on the entire western side and still block it. Still use good sustainable design principles, and then of course I'll try to convert the client also, saying, okay, what they're looking for is more modern. Does it really have to be only glass? So, but it's important to hear what the client is saying. You have to hear carefully and use your wisdom and judgment to negotiate that, to achieve what meets the client's aspiration. Because if that client needs to hire 5,000 BPO workers and they get attracted by slick buildings, then that is his reality. So I'm not saying then you turn around and say, okay, then fine, I'll make anything. No, you have to consider that as a parameter as well. Right. And see how to make that come up as good architecture. And by good, if it doesn't involve sustainability, it's not good.
Not good. Yes, right. I think that I'll take that as a big lesson. Thank you so much, Sonali. And over to you, Aarti.
Thank you so much, Sonali. It was wonderful. Mahesh sir, should I be giving vote of thanks, or do you want to take photographs and screenshots?
No, you could do your vote of thanks then, or we could start everyone's video after that. Yes.
Okay, ठीक है. Thank you so much, Sonali. It has been a wonderful session. In fact, your work speaks volumes about your passion and your persistence. And it was probably a perfect blend of architecture and landscape, architecture and sustainability, and beautiful, beautiful. I mean, I'm sure there's a lot of inspiration that students can take from this. Most important, I feel, is what they keep thinking about sustainability as a very drab kind of issue. It's not so. It can be very, very interestingly weaved along with architecture. So thank you so much on that note. With this, I would officially like to thank all those who have helped make this event possible. Thank you, MKSSS and Dr. Kashyap, for always being positive and supporting our endeavors. Thank you, IT department, admin, our own faculty, Mahesh sir. Thank you, Shruti Kubar and Shruti Dhivar, who have been instrumental in designing the poster for this event. Thank you, audience, also for being so patient listeners. I wish to thank all the eminent professionals and the faculty and the students who have graced this occasion. Last but not the least, I would like to thank my entire team who have worked diligently towards making this event possible. Thank you, Ritu, also for being such a wonderful coordinator for this event. Yes, Mahesh sir, over to you.
Yes,
and Sonali ma'am,
we
would like to have you sometime in person. We would definitely
Oh,
like to
absolutely.
interact with you. And let's see how we can plan out probably a workshop or some other event where we can actually interact with you. It would have been a wonderful event otherwise.
I would have enjoyed that as well. I'm hoping the world is a better place in a couple of months.
Yes, let's hope all of us, let's hope so.
Yes, and I've just received a message from our environment department saying we would love to have you associated with our MH environment department because there's so much of sustainability that you spoke about, and that too so subtly that we have so many initiatives at our MH environment department which you could guide us on and help us with. So you're most welcome to visit the institute whenever best possible now. So thank you so much, and I'm going to allow the participants to switch on their videos. It will be best to have a few of you start your videos so that we do a screenshot as a memory. Yes, just a moment, just making sure everyone is seen. Yes, give me a moment. Yes, great.
It's so good to see our faculty join with the kids.
And she's doing her environmental architecture masters as well. So yes. I think very relatable to
Professor Rajiv Raje.
Yes.
Good evening.
Just a moment. I'll just make a screenshot. Thank you.